Alright, let's dive into the ultimate face-off, monoliths versus microservices. Which one is better? Well, it's like asking if a food truck is better than a full-blown restaurant. Each has its perks and a few spicy challenges. A monolith is the old-school, one-stop approach. Imagine an e-commerce app where you have all the goodies: user service, catalog, shopping cart, payment, discounts, sales dashboard, packaged up as one single happy application. It's simple, straightforward, and all under one roof. But here's the catch: if there's a bug inside the payment module, you have to redeploy everything. Yep, the whole shop shuts down for a reboot, even if it's just one tiny hiccup. Plus, if your sales dashboard suddenly needs to handle tons of traffic, the entire app gets dragged into scaling, even if it doesn't need it. At this point, microservices come to the rescue. With microservices, each component is its own mini-service, living its best independent life. So, if component A has an issue, you only redeploy component A. Scaling up, just boost the services that need it. No need to work the whole app along. Teams can also work at their own pace. Team A can push updates every week, while Team B can take it easy with monthly updates. It's efficient, flexible, and just smooth. But of course, there's a plot twist and some challenges.
Challenge number 1: deployment.
The deployment of microservices involves managing multiple service instances and replicas. This makes it impossible to deploy microservices in the traditional way an application is deployed. That is why containerization tools like Docker and container orchestrators like Kubernetes become a must in the microservices world.
Challenge number 2: service discovery.
In a monolithic app, modules call each other directly, using function calls. The function calls are fast. They are executed in several clock cycles and typically take some nanoseconds. But microservices? Service A can't just call service B. They are now practically different applications, maybe running on different server nodes. It's now like sending messages across town, no more in-app chit-chat. They need to use the network to communicate, which is way slower than a function call and measures in milliseconds. This is actually a million times slower execution. To solve this and improve the performance, we can have multiple copies of service B. But then how would service A know the IP addresses and port of all service B replicas? And how will it balance the calls to the multiple service B replicas? A load balancer? Yes, we can have a load balancer in front of each service. This will solve the issue of addressing multiple service instances, but it will introduce different challenges. There will be a lot of load balancers, practically one for each service, compared to the monolith approach where you have only one. And each of these load balancers will be a single point of failure. In case of issue with the load balancer, the corresponding component will not be accessible. Also, adding a load balancer will increase the network latency, as there is one more hop in the line, and those load balancers need to be managed. New service instances should be registered in the load balancer, and old ones should be removed. Kubernetes as a container orchestrator solves this issue by implementing built-in service discovery. In Kubernetes, each service instance is automatically registered after its successful startup. Each instance can query the cluster and ask for the location of another service instances. This enables services to locate each other dynamically.
Challenge number 3: configuration.
In a monolith, you've got a couple of configuration files to update when needed. Easy peasy, but in microservices you could have hundreds of instances all needing the same configuration update. Having a local configuration file for each service instance will cause a lot of operational overhead, like rebuilding and redeploying the container images just for changing the configuration. A better approach will be if the configuration is centrally managed and every change is propagated to all instances. In Kubernetes, this is achieved by using the so-called config maps. The config map is a Kubernetes resource that allows you to store configuration data as key value pairs. Those key value pairs can then be mounted inside the containers like regular files, or set as environment variables. Config maps make it easier to centrally manage and update configuration settings for applications running in Kubernetes.
Challenge number 4. Network segmentation.
Monoliths are simple here too, with clear-cut zones for everything. The DMZ, the app zone, and private databases zone. But in microservices it's chaos. Each service should have its own rules about who it can talk to. Firewalls help, but setting up hundreds of firewall rules for each and every combination of service instance and port, yikes. Plus, as traffic is going over the network, we've gotta be extra careful. It's a common assumption that if the network traffic is local, it is secure enough, and it is unlikely to be attacked. But in current times, this is a risky assumption. It is always recommended to implement zero trust security and encrypt the communication channels between the individual microservices. And how are those network challenges solved in a container orchestrator like Kubernetes? Kubernetes does not have a native built-in solution for achieving such service-to-service traffic isolation and secure communication. But service mesh tools like Istio and Consul help to provide those features. With a service mesh, you can define who can talk to who and secure the communication between the parties. How is that achieved? The service mesh typically uses mutual TLS, so every service knows who is who. No imposters are allowed. A second advantage of using MTLS is the encrypted channel for the data that is flowing between the microservices. So, which is better, monolith or microservice-based approach? Well, monoliths keep it simple and cost-effective, making them great for smaller projects. But as things grow, microservices are the way to go, offering independence, scalability and flexibility. Want an example? A small e-commerce site? Sure, go monolithic. A global platform like Amazon? Microservices all the way. Thanks for watching. What's your view on the topic? Are microservices the better approach for building a new application? Please share in the comments.